Imagine looking not excessively far off and seeing a sunrise that includes a portion of the sky. NASA has conveyed photos of a previously unheard-of characteristic where a star named Betelgeuse went crazy, catapulting a monstrous piece of its surface mass. The event is known as a surface mass launch, and according to the Space Association, the release was multiple times the mass of a typical solar flare from our Sun. Analysts describe the event as watching great improvement continuously, with a star taking off such huge chunks of its real design. Amazingly, the tragic impact of this bright red beast is upsetting a lot of what we are familiar with regarding the universe. Why did Betelgeuse go crazy, and how should that impact the universe? We ought to sort it out. Great bodies are involved, many stars are coordinated by legends and myths, and they are still utilized for navigation today. One such star is Betelgeuse, which is among the greatest and most brilliant stars in our evening sky. The splendid ruby-red shimmering star known as Betelgeuse is arranged in the upper right shoulder of the constellation Orion. When seen carefully, stargazers remember it as a raging monster with a multi-day-long heartbeat of regular pulsates. As a result of its disturbing orange-red tone, Betelgeuse is easily remembered. It's ideal for convincing doubters that stars do, in fact, have different tones. It is also called Alpha Orionis and is the second most brilliant star in the constellation after the blue supergiant Rigel. Betelgeuse is a spellbinding object for star studies and observations because of its variable nature, as well as its odd name. Routinely, stars with the name Alpha are the most brilliant stars in their star groupings. In spite of the fact that Rigel, Orion's other brilliant star, is more brilliant, Betelgeuse is Alpha Orionis due to its name, brightness, size, and bronzed color. It is also maybe quite possibly one of the most striking stars. The fact that this star filled in as the model for both the character and the film Betelgeuse makes it significant. The star is the seventh most brilliant star visible from most of North America, Europe, and Canada, and it is the 10th most brilliant star generally overhead. Earth is relatively close to Betelgeuse. Space specialists can't pinpoint Betelgeuse's accurate distance from Earth, despite the fact that they trust it to be somewhere in the range of 430 and 724 light-years away. Betelgeuse is the most brilliant red supergiant star and is closest to Earth in our universe. There are only 200 red supergiant stars that have been identified. The Sun has a radius that is multiple times greater than Betelgeuse. Assuming the star supplanted our Sun in the planetary system, it would reach past the asteroid belt and, indeed, even past Jupiter. This suggests that Earth, Mars, Venus, and Mercury would all be totally ingested. Betelgeuse is on various occasions as enormous as the Sun. This very beast has 12,000 to 26,000 solar radiances and is apparent from 548 light-years away. This star has a surface temperature of around 3,600 Kelvin, making it cooler than the Sun. Almost 13.3% of Betelgeuse's splendid energy is clear light. If natural eyes could see light at all frequencies, Betelgeuse would outperform Sirius as the most brilliant star in the night sky. Betelgeuse loses around 1 solar mass each 1,500 years. The red star is encircled by a cloud since this material is being shot out unevenly from the star. Each direction, a fog of material multiple times greater than the star includes Betelgeuse. The size of this cloud is additionally remembered to be 30 astronomical units, or on different occasions the solar distance. The Sun and Neptune, the farthest planet in the planetary system, are separated by this distance. Our planetary system Sun continually dispatches mass into space, which is known as solar flares. Anyway, the Sun, as it were, inhales out small segments of its external atmosphere known as the corona, giving the peculiarity the name coronal mass ejection, CME. Therefore, coronal mass discharges and surface mass launches can occur at isolated times when a star releases part of its unstable external atmosphere. It causes a CME known as the crown. CMEs from our nearby planetary group happen every now and then and can influence Earth and its occupants. CMEs can travel more than 1,800 meters per second while sending off attractive fields and plasma into space, sometimes showing up on Earth within the space of hours. A CME can disturb and harm Earth's satellites and power systems when it occurs on the Sun that faces the planet. Additionally, it irregularly puts astronauts in orbit in peril. The new discovery reveals insight on the strange causal reason for Betelgeuse's changes. Coming from 2019, the material that the star jump-started out exploded into space, cooled, and made a haze of colossal residue that disguised Betelgeuse's brightness from Earth-based eyewitnesses. Besides, Betelgeuse's esteemed consistent beating design has been modified. The CME on Betelgeuse is astonishing since it delivered 400 billion times more mass than a normal CME, which made the star shade like a dish of gelatin treats. As indicated by a NASA news release, Andrea Dupree, a space master at the Center for Astrophysics, stated that the star's inner convection cells may be in chaos while its photosphere or star surface battles to replicate itself. Cosmologists have been following the star's reliable pattern for the past 200 years. Yet it no longer exists. All red giants, including Betelgeuse, are dying, and having the option to see this interaction will permit experts to acquire significant insights into the advancement of stars. Most stars in the universe are fueled by atomic fusion, which eventually runs out and causes a star to go through a progression of captivating changes before it eventually kicks the bucket. When a star is conceived, it is made of hydrogen, which under the power of gravity fuses in the star's core to make helium in an atomic impact. A ton of intensity and light energy is consistently generated during the fusion cycle. This energy moves to the star's surface and is produced as a photon into space. As the star ages, its primary fuel, hydrogen, runs out, and helium begins to meld with carbon to form carbon. Later, when the helium is spent, neon will ultimately intertwine with carbon to shape oxygen. When this happens, the fusion of neon with oxygen absorbs energy rather than delivering it. Since there isn't anything to counteract the star's strong gravity, when oxygen starts to meld, the star implodes on itself, prompting a cosmic explosion, a cosmic blast. A cosmic explosion, one of nature's most amazing powers, can produce more energy than 10 billion suns. Stars change tone during the course of their existence, from the youngest, hottest blue designs to the older, cooler red varieties, depending on what period of their grand improvement they have reached. The Greek scholar Timo in 168 AD curiously alluded to Betelgeuse's tone as having a bronze color. 3 centuries prior, Chinese astronomers had described the star as having a yellow appearance. Conceivably, it was once a yellow supergiant. Cosmologists may acquire a better understanding of how red stars lose mass in their last days before exploding in a brilliant cosmic blast. From Betelgeuse's impact, as Dupree notes, we've never seen a huge mass launch on the outer layer of a star before. We are left with something going on that we don't totally comprehend. It's an altogether new peculiarity that we can notice straightforwardly. Furthermore, resolve surface subtleties with Hubble. We're watching sublime advancement in constant, yet it's hazy whether this improvement predicts Betelgeuse's looming cosmic blast. As the results are so astonishing, NASA issues a cautioning that Betelgeuse probably won't have arrived at the finish of its life. Despite the fact that it is moving toward the end, tremendous time is long, and red supergiants pass on rapidly by comparison. According to NASA, Betelgeuse will detonate in the following 100,000 years. Betelgeuse has been the subject of huge studies starting from the 1st century BC. More as of late, a specialist by the name of Saran Nance and her group attempted to become familiar with the reasonable timing of the cosmic blasts of red supergiants like Betelgeuse to sort out how a star that huge would act over time. Nance and her group ran different reenactments including Betelgeuse as a model, and they then looked at their discoveries to handle observations. Why did Betelgeuse abruptly faint, conflicting with its customary cycle, when it will likely not detonate for another 100,000 years? Betelgeuse was removed from its home in the Orion OB1 Association, which remembers the stars for Orion's belt, and has been seen going through the interstellar medium at a speed of something else than 4 light-years wide. By mid-February 2020, Betelgeuse had lost 2.5 times as much brightness, dropping from magnitude 0.5 to magnitude 1.7, in the wake of beginning to diminish emphatically in October 2019. By February 17, 2020, Betelgeuse's brightness had been steady for just about 10 days, and the star had started to illuminate once more. Anyway, Betelgeuse appeared to have quit darkening totally 5 days after the fact, successfully finishing the diminishing episode. Considering that there were no significant changes in the infrared on February 24, 2020, It gave the impression that the new visual blurring was generally irrelevant. A review inferred that the star's diminishing was reasonable, brought about by a haze of gigantic circumstellar dust. Ingestion was precluded from having a significant effect in a review utilizing estimations at submillimeter frequencies. Yet the darkening has all the earmarks of being brought about by enormous star spots. Further examination showed an emotional ascent in Betelgeuse's splendor among May and August. Betelgeuse is so close to the Sun that it is incredibly hard to see from Earth. Before 2020, when Betelgeuse was connected with the Sun, it was likewise 0.4 in brightness, according to observations made with the Sounder satellite in June and July of 2020. The star had blurred by 0.5 since its previous ground-based observation in April. Everybody was stunned by this because the maximum and coming about least were supposed to occur in August and September 2020 and around April 2021, respectively. Betelgeuse's brightness was known to change broadly, making forecasts troublesome. The darkening appeared to show that a second darkening occasion could happen a whole lot sooner than anticipated. The revelation of a second dust cloud coming from Betelgeuse, which was connected in June 2020, suggested that a cool patch on its photosphere may be the reason for the residue. In August, a moment-free examination affirmed the introductory hypothesis. The residue is thought to have been made by the gas the star had removed. Studies done in 2022 utilizing the Hubble Space Telescope suggested that a residue tempest could have been made by a surface mass launch. The material was darted away from the star's surface, thousands of kilometers away, where it cooled, compacted, and formed the star's diminishing residue. The harmed photosphere, which was multiple times as gigantic as our moon, went into space, cooled, and shaped a residue cloud that covered the star. According to the perspective of spectators on Earth, the diminishing, which began in late 2019 and gone on for a couple of months, was obviously perceptible even by casual spectators who saw the star's brightness change. More astounding, the 400-day beat pace of the supergiant has vanished since around 200 years ago. Cosmologists have been following this cycle by breaking down changes in Betelgeuse's surface developments and brightness varieties. Its disturbance uncovers the size of the effect. Cosmologists have now fostered a probable speculation to make sense of the unsettling influence. The star is additionally leisurely, however obviously, reconstructing strength, and the photosphere is recuperating. The star's normal cycle is being lost, and the inside is vibrating like a bell that has been struck. A monstrous heavenly surface mass discharge has never been seen before. There is still something going on that we don't completely comprehend. We may straightforwardly notice this completely new peculiarity and use Hubble to notice surface highlights in real time. When will it happen? Probably not in the course of our lives, but nobody really knows. It could be as a matter of fact tomorrow or a long time from now. Will Earth be demolished by Betelgeuse's cosmic explosion? No, the impact of Betelgeuse won't influence or annihilate life on Earth since it will occur very far away. For it to influence the world, cosmologists estimate that for a cosmic explosion to be unsafe to people, we would need to be within 50 light-years. Additionally, Betelgeuse is in excess of multiple times further away. Rather, everybody on Earth will be treated to a remarkably shocking perspective on an exceptionally brilliant star in the evening sky. At last, due to Betelgeuse's location, space experts will have the option to concentrate on the star when it undergoes a cosmic explosion. Betelgeuse isn't at present apparent in the night sky, so don't go looking for it. Regardless of whether it detonated right now, we wouldn't see quite a bit of it. Anyway, it is in the midday sky during August. Betelgeuse might have previously gone supernova. Betelgeuse, or Betelgeuse, isn't simply a critical star in the Orion constellation, but it also plays a fundamental role in the investigation of heavenly evolution. Its size and extraordinary qualities make it a brilliant research facility for grasping the life patterns of gigantic stars. The star is delegated a red supergiant, a classification that incorporates a portion of the largest and most splendid stars in the universe. Observations suggest that Betelgeuse may ultimately go through a huge change, prompting a great cosmic explosion event. This blast is anticipated to create a neutron star or conceivably even a black hole, relying upon the residual mass after the explosion. Specialists are anxious to gather more information about its behavior, especially concerning mass loss rates and surface changes, which can give bits of insight into comparable stars across the universe. Notwithstanding its logical significance, Betelgeuse has additionally caught the public imagination. Social references like the 1988 film named after the star have solidified its place in popular culture. As it advances close to the furthest limit of its life cycle, interests encompassing Betelgeuse keep on developing, featuring its importance both deductively and imaginatively.